So thank you very much for coming. My name is Rui. I'm a software developer at Oracle / MySQL. And today I'm going to talk to you about the DevAPI and how you can leverage it to build your applications and the benefits it brings to you as an application developer. And I hope that you are developers. So who's a developer in this room? No? DBA? One? Okay, 2 DBAs. Interesting. Okay. Okay, maybe this is interesting to you anyway. Okay, so this is intended just to tell you that everything I'm about to say is a lie and you can't do anything about it. No, I'm kidding. Yeah, policies and all that. So yeah, I work at a team called MySQL Middleware and Clients under the MySQL umbrella. I'm the lead developer of the Node.js connector for MySQL, and those are my contacts there, my work email, and my Twitter handle. So if you have any questions regarding this talk or regarding anything else, in particularly related to MySQL Node.js connector, please feel free to reach out. So this is the agenda for today. We're going to start to talk about what's the status quo of MySQL or MySQL and the building blocks for what we see today as modern MySQL and the brand new features that the latest release of MySQL has brought and the benefits for developers, so it will be the main focus. Then we will dive a bit into the DevAPI. Then I'll show you how you can actually use the DevAPI. So I'll go through the API itself to show you how you can implement it in your programs and your applications. And then some closing thoughts. So yeah, there's a constant debate between why SQL, why NoSQL. This is a never-ending, seems to be a never-ending cycle, and the pendulum is constantly swinging back from one to the other. Nowadays, I guess SQL seems to be trendy once again, and that led to people starting to call what was meant to be NoSQL back then to now mean not only SQL, because SQL is great after all. So that means that there's probably a need for the two. However, we as application developers shouldn't have to care about this kind of discussions. Things should be available to us to create our products and to be productive. That's the most important thing for a developer, I think. And with MySQL, you actually don't have to care about this discussion anymore because the new versions of MySQL bring you the goodness of NoSQL and SQL altogether, and you don't have to worry about all those things and don't need to choose between one. How does this work? So this started off with the JSON data type support for MySQL, which unlocks a wide range of use cases and fulfills the application developer needs regarding unstructured user data. And then came the MySQL document store, which is pretty much an abstraction over the JSON data type. There was a talk before where I spoke a little bit about the document store more in detail. I won't be covering that much in this talk. Of course, it's all based on InnoDB, which brings all the ACID goodness you have on regular MySQL, table-based MySQL, whatever. Then you can also tap into other things like the InnoDB cluster with the MySQL router, which also speaks the protocol that the DevAPI is built on top of. and we will talk a little bit about it later. I won't talk about InnoDB cluster because there are other talks in this conference that are totally focused on that. I hope you had the chance to attend those. Yeah, and as I was mentioning, SQL nowadays seems to be coming back, and yeah, it's effective, it does its job, and it fills in the holes where NoSQL would probably not ever be able to perform. So yeah, this is a statement by one of my colleagues, Fred, which has a blog post about the reasons why you should use MySQL for your NoSQL and SQL workloads, and I encourage you to check it out. So the document store, just a quick overview. It's a way to deal with unstructured data using a MySQL database. It's an abstraction over the JSON data type, already mentioned it. And it allows to map data structures on the client language, be it Python, Node.js, Java, C++, PHP. There are at least these connectors that implement some sort of API to access the document store, in this case, the DevAPI. And it allows you to basically map these object structures on those languages to documents in the database or JSON data in the database. And by using the document store, you don't have to worry about schemas or strict data types, and you can actually leave SQL altogether, although that's totally optional. And at the same time, you can use NoSQL and still keep the logical consistency and ACID properties of the database, in this case of the data engine, which is InnoDB, as I mentioned. And besides using document store collections and documents, you can also mix in traditional tables and rows, so there's no limitation on that scope. So this is a quick overview of what would be like a MySQL stack nowadays, with an application connecting to the MySQL server via the classic protocol. This used to be the way that things worked. It still can work like that, but now you have a different option, which is by going through the DevAPI and the new protocol called the X protocol, which speaks with a server plugin called the X plugin, and this is basically the flow that implements the document store data access patterns. So in terms of applications, so what do you get from all this? So, and what are the requirements of most applications nowadays? So developers are always in search for flexibility and ease of development, of course, and better productivity or increase of productivity. Easy mechanisms for deploying and scaling their applications and also securing their applications. These are probably the most interesting aspects of the DevAPI that benefit applications, as we will see. And what do I mean by being carefree and building carefree applications is not having to worry about having either a single server or having a cluster, having a cloud service, whatever. As I mentioned before, also using either a relational database or a NoSQL engine, whatever. Not having to worry about deploying a monolith or deploying multiple services on multiple platforms. And not having to worry about actually securing the database and being aware that the database is actually secured by default, so they don't need to work on that part of things, and that makes them do things more quickly and get to market more quickly, which is the most important thing, as I mentioned. So the DevAPI itself is a database API that allows to develop MySQL-based applications and once again unlocks access to this document store feature I was talking about. Um, it unifies at the same time an API for accessing traditional tables, SQL relational tables, and also collections on the document store. So it unifies that under the same umbrella. And it does that by using a bunch of CRUD APIs, both NoSQL and all NoSQL or SQL in the case of relational table-based APIs. And at the same time, it also allows you to resort to raw SQL statements if you need. It's a standard specification that is available on all the official client implementations, the ones I mentioned before. Right now, the MySQL team is maintaining implementations for PHP, Python, Node.js, Java, C++, and .NET. And besides that, it's also implemented in the brand new MySQL shell, in their, specifically in their JavaScript and Python interfaces that it supports right now. It's described in detail in this link, so I encourage you to go there and read a lot more about it. It covers a lot more than I will ever be able to cover in this presentation, and we have a question. Okay, so the question is, why implement a new protocol instead of using HTTP and REST as a protocol?
The OData protocol which defines the CRUD API.
That's a good question. I think that I haven't talked about the X protocol right now. I will be doing a quick overview, but the thing is that the X protocol is based on Google protocol buffers, which is a lot more it's a lot faster, I believe, than using like regular HTTP protocol and using HTTP parsers and stuff like that. And we get those things out of the box, and they are a lot less complex than those kind of protocols if we were using like an HTTP protocol with JSON. As far as I can tell, it would be a lot slower, but I'm not an expert. But that's the idea I get from it. At least that's one of the reasons. There are probably more reasons. The fact that you have a lot of tooling behind protocol buffers, and it allows developers to build other stuff on top of it and to actually create interfaces easily by using like stubs and stuff like that that are created by the Google protocol buffer specifications. Exactly, but I mean, there's so the remark is that HTTP and JSON is a lot more used by developers nowadays that are building applications, and that's a good point. And once again, I think it all relates to the performance part of it, and also, I mean, we can. It's a good discussion because I mean we can also discuss that HTTP and REST in particular. Developers are actually moving away from it and to stuff like GraphQL and things like that. So yeah, it's an argument we can have, but I don't have any side on that discussion, to be honest. But so yeah, the X protocol. Moving on, this was about to answer your question. So it's a client-server protocol that it's implemented using Google protocol buffers, and it makes that easier for anyone to extend and improve because it's open. There's a lot of tooling around it, and you can easily create interface. You don't even have to do anything. The tooling can just create the interfaces you need to interact with or to implement the protocol. So there's not a lot of work in it. You just have to declare the types of messages, and then interfaces are automatically built for you. Like, I mean, once again, this all comes to the question of everything working in cycles in terms of software engineering, because I recall this was also the way that Corba worked a long time ago, and now it seems to be trendy once again. Don't ask me why, but I guess it's performance. That's the best explanation I have for this. Again, widely available tooling for building stuff. It's middleware friendly in a way that each node in some kind of system is able to implement the interface easily and read and write stuff without any kind of proprietary knowledge, let's say it like that. It's secure by default in a way that it allows to perform placeholder binding at the protocol level, so there's no more SQL string mashing and risk of SQL injection and stuff like that. I mean, we can mitigate that risk. The risk is still there, but the protocol allows anyone to overcome that. And also because it doesn't, using the X protocol, servers don't expose sensitive information to either unauthenticated or authenticated users. The way the protocol works is that, for instance, if the client wants to know if the server supports a certain feature, it doesn't need to resort to version sniffing or stuff like that. It just sets an expectation, and the server will reply saying that it supports or it doesn't support that feature, and the client can do whatever it wants, and it doesn't need to sniff the version or sniff any kind of thing. So it makes it secure that way as well. And also, it's also one of the components that makes it middleware friendly, I guess. Open source as well. You can check out the specification in this link. The middleware friendly part that I mentioned is pretty much described here, that messages encapsulate well-defined database objects and actions. So like, for instance, a CRUD operation is expressed by a specific data structure that contains all the details of that CRUD operation. And it's a Google Protocol buffer message itself, so it makes it easier to understand as well. The CRUD expression, so the CRUD expression is defined by an expression syntax, as we will see later. But the operation itself allows to establish pretty easy operation boundaries with those placeholder bindings I was talking about, and other stuff like projections and limiting data in the result set, etc. Those things are actually pretty well defined in each message. So, and those expectations I was talking about, where we can have operational conditions based on what kind of features the server provides, and we can actually also use them to create pipeline statements and send multiple messages to the server and expect responses later, so in an asynchronous fashion. Okay. Oops. So the security awareness, I already touched on this. In this case, X protocol communication uses TLS SSL by default. It supports all the authentication plugins available in the server, and also custom authentication plugins that you may want to implement. No information is leaked because of that expectation feature I was talking about. And SQL injection is mitigated because of the placeholder binding with strict typing defined by the Google Protocol buffer data types. So the X protocol talks to something called the X plugin, which is a plugin that exists on the MySQL server, and it is installed by default since MySQL 8.0 11, or at least the GA version of 8.0. I won't go into too much detail about the plugin because it's a server-side component, and I'm not really a server-side guy, so I already mentioned this. It's what actually provides the document store infrastructure on top of the MySQL server. It uses a different set of ports. In this case, it uses 33060 instead of the old 3306 that the classic protocol used. It implements the server-side X protocol interface and accepts client requests made via the X DevAPI and processes them using the core MySQL engine. Documentation is available on this link as well of how you can get started and an overview of the X plugin and how it does work in the scope of the MySQL server. So just to show you a little bit of what this means. So using the DevAPI, you can create a query like this, which is translated into a protocol buffer message like this at the X protocol level. I don't know if this is readable. I think it is, but this is a stringified version or JSONified version of the protocol buffer message that gets sent, because on the wire it's obviously binary. And this then gets interpreted by the X plugin, which converts it to the appropriate SQL query that gets processed by the MySQL engine. So talking a little bit more about the DevAPI. So it wraps powerful concepts in a simple interface, and this is mumbo jumbo that's actually written in the documentation, but it's true. I mean, you don't have to worry. I already talked a little bit about this, because you don't have to worry about those things like, do I have a single server? Do I have multiple servers? Whatever. The code just transparently scales between them. Operations are simple, expressive, and easy to use. As I showed before, in the DevAPI, you just write a simple operation using a Fluent API that actually creates the underlying statement, which you don't have to deal with at any point in time. The statement is just created at the server level. And it provides non-blocking and asynchronous flavors on most of the platforms it supports. I think there's one or other that doesn't support it, but Node.js obviously supports it, and I think there are also async implementations on platforms like Java and .NET, I believe. I don't know about the others. And there are also there's an autonomous behavior that makes it different from a regular relational database management system driver that uses plain SQL. There are some stuff like prepared statements that are actually server-side prepared statements that work in a way where the client implementations basically understand if the application is trying to actually reuse a given statement, and then they prepare the statement for the application. The application doesn't need to use an explicit API to create statements or stuff like that. And we also do the same thing for automated failover on connection, and also timeout management, stuff like that, and connection pooling as well. So in terms of how things actually work underneath, documents are stored in the collections and have their dedicated operation set defined by CRUD methods. It works with the main objects, as I mentioned, and is able to auto-generate like data structures for the specific platforms and languages that it matches then with the document in the database. And the focus is put on working with those CRUD operations, even for regular tables. And yeah, it favors like query building and ORM kind of usage over traditional SQL string mashing. Although you can use SQL, nobody prevents you from using it. On the DevAPI, there's an API for that as well. So yeah, what's in the DevAPI, the XDevAPI? So you get a Fluent API, as I mentioned, where you compose multiple steps to create an operation that then gets sent to the server. And the API supports flexible parameters. You get that hybrid CRUD API for both NoSQL and SQL, so for collections and tables. Things like filtering criteria and projections and quite a few other things are described using a small and portable domain specific language that it's a subset of SQL, so it's a lot more simpler than SQL, but it's also powerful like SQL is. Once again, you can mitigate SQL injection via protocol level placeholder binding with the XDevAPI, of course. You have an API for creating transactions and creating save points or deleting save points and committing and rolling back transactions, and also for role locking when you are doing selects. Multiple connection modes, either single connections or connection pooling, of course. Those automated server-side prepared statements I was talking about, connection failover and timeouts. Multiple SSL and TLS operation modes and the authentication mechanisms as well. So the Fluent API, there's a single point of entry. You either create a single connection using a standalone session, or you can create a connection pool using the get client method. The Fluent API makes things more readable and maintainable, and also, by consequence, also a little bit more testable, I believe. The operations are encapsulated in specific methods, and the fact that it's Fluent allows for better scaffolding for providing hints and auto-completion and refactoring and other kinds of tasks that the IDE can perform for us or can help us perform, basically. It also by consequence, allows for a smaller SQL surface area, so less error-prone as well in that aspect. And it's a common standard between different platforms. So we try to. So the API, it's pretty much the same on the different platforms that where it is implemented. There are some differences that are specific to some platforms, like result set handling on Node.js is a little bit different than the other platforms, or it used to be. It will stop to be in the next version in 8.0.18. There would be a unified interface for handling result sets, which is similar to Java, for instance. So basically, if you want to create a CRUD operation in Java, it's pretty much it depends a bit on the kind of operation, but most operations are actually totally equal. So word by word and letter by letter, it's exactly the same code on in this case Java or JavaScript or other platforms. But so the flexible parameters I was talking about before, you can provide, in this case, when you are creating a section, you can do it using a connection string, or you can use like plain JavaScript object in this case, or you can use in languages that don't actually support plain JavaScript objects, of course. You can do it like with specific instances of a connection that also encapsulates this kind of properties. Another example, so collection add, we can call add multiple times to add multiple documents, or we can just provide an array with those documents and they would be added as well. Now, binding can happen with, we can bind a value to a single placeholder that is defined on those operational boundaries that I was talking about, that are defined by the expressions. In this case, it's a filtering criteria expression where we are searching for a document by name. We can tell the operation what is the name that we are looking for, or we can tell other things to the operation. And again, we can use like an object in JavaScript to do that. We can use a JSON string. We can use a Python dictionary, whatever. So projections, we can pass multiple arguments to project, or we can pass a list of arguments to project. The hybrid CRUD API I was talking about, so it differs a little bit between collections and tables. So table is more SQL-like, and collection is more document store-like, if you like. So there's add, find, modify, and remove for collection, and insert, select, update, and delete methods for table operations. And the boundaries are defined through that domain-specific language I was talking about, which is a small subset of the SQL language. And I mean, everyone already knows SQL, I hope. Maybe not, but but it's a well-known language. So it's easy to grasp. And since this is a smaller subset, it's a lot easier to work with. It's human readable and expressive, so it's not like some kind of object where you have dollars and numbers that tell which items in the document need to be projected or not, those kind of things that exist on other products. It's a common standard, as I was mentioned, so the expression syntax is always the same on whatever client that implements the XDevAPI, be it one of the connectors or the XDevAPI shell. It's used for stuff like filtering criteria, computed projections, and placeholder assignment, and also result set ordering. Some examples here. First one, we are just using a placeholder for filtering criteria, and then we provide a value for it. Second one, we pretty much do the same thing, but without the placeholder. This is an example of using a computed projection where we can actually, so there's this expr method which allows us to build those expressions on the client side, and then the plugin will be able to understand what's going on. In this case, I'm just using this concat function, which is actually the MySQL concat function. So I can append stuff, in this case, to one of the properties that I need to work with. In this case, I'm using a name property of a given collection or given document in a collection. So this is also an expression for ordering. Talking about placeholder binding, as I was alluding before, so the assignment is made via that specific API construct, which is the bind method that I showed. And if you use that, there's no chance of string concatenation without sanitization of the values that are provided. And the values are bound to the placeholders at the protocol level. And the protocol uses strict definitions to actually enforce that sanitization and that validation at that level, basically, using the protobuf data types. So there's less risks of SQL injection and similar attacks. Already showed how this works, but just to give you a couple more examples. It also works with SQL statements, as we can see here. So the first two are what we call named placeholders, where the expression defines placeholders by name using a tag. And if we resort to SQL, in that case, we are only able to use what we call anonymous placeholders. So you basically provide an interrogation, a question mark that defines that it should exist a placeholder there. And then the values that you provide to them are assigned in the order of, in order, basically. So the XDevAPI also allows to work with transactions and save points, create transactions, commit and rollback transactions, create save points, roll back to a specific save point and release it, row locking as well. So all the ACID and consistency goodness that MySQL provides is always available on the XDevAPI, no matter if you are using relational stuff or doc store stuff. The different connection modes I talked about, you can get a standalone connection and encapsulate it in a MySQL X session using a connection string or whatever, and you can create a connection pool using that same connection string like this, where you provide like specific pooling options. In this case, these are all the options that are available to create the connection pool, so it's quite simple. There's not a lot of things that can happen. And in that case, you just acquire connections from the pool using the get session method. Failover and timeouts, you can define specific timeouts using single hosts, or in case of multi-hosts, where you can define the list of hosts where the client will try to fail over, basically. So there are different notations to do that. These are just a few examples of how it can work. There's also this priority-based notation, which is pretty much the same thing as the other examples, but it's explicit about the priority. In the other ones, basically the priority is defined by the position of the endpoint or the host and port tuples in the array. The last example, it defines explicit priorities, so that's the only difference there. Yeah, you can enforce strict SSL settings. Also, SSL is enabled by default. You can do stuff. You can do things like providing certificate authority, providing certificate revocation list as well, and the client will try to match that with the ones that are provided by the server, or will validate those against what is actually allowed by the server. Multiple authentication mechanisms, as I mentioned. All these map to server authentication plugins, in this case. Yeah, so how can we put this all together? So yeah, we already saw how we can create a session. We can get a specific schema for that session and check if it exists or not. If it exists, if it doesn't exist, we can create it. Otherwise, we will get an error. Or we can connect to an existing schema. If we know it already exists, we can just provide the schema in the connection string, the schema name in the connection string, and then we can access that schema in our application using the getDefaultSchema method. There's some more boilerplate here. We can get a list of schemas that are available, of course, the list of collections in that given schema, the list of tables as well, so you are able to distinguish between what are actual tables and what are actual collections. Although a collection is underneath is just a table, but the protocol is able to abstract that, and you are able to understand exactly if you are working with a doc store collection or a relational table. Creating collections. In this case, we can actually instruct the client to reuse an existing collection if it exists. And in this case, we won't get any error if we are trying to create a collection that already exists. Adding documents to a collection is as easy as this as well. You just provide the document structure to the add method and you call execute. If you don't provide an ID, the server will generate one for you. So there's also add or replace one, which will replace a document with that given ID if it already exists. If not, it will add. So it's basically an upsert. So right now, there's no table DDL API. So if you want to create tables or delete tables, stuff like that, you would have to resort to SQL. Although you can call CRUD operations on a table after it is created. So just the DDL part that is missing. So you can call insert and you can insert stuff in the table, call select, update, and delete as I showed you before. So retrieving data from the database, in this case, from a doc store collection. Again, similar pattern as we saw before. We call find, we provide a filtering criteria expression with placeholders, and we bind values to those placeholders. We can project the properties of the document that we want to show. And then reading them is as easy as calling fetch all on the result. It returns the entire list of documents that has been retrieved. There's also fetch one, so it's basically a pull-based cursor. In this case, the cursor moves along and consumes the data in that specific element in the result set. There's also other utility functions like getOne, which allows you to retrieve a document using its ID, basically. So one-off functions, you don't have to compose operations to retrieve the data if you know the ID of the document. Modifying or updating stuff, same thing, only the method name changes pretty much. It allows you to set individual items to update individual properties in documents, or it allows you to update multiple properties in documents using the patch method in this case. Again, add or replace and replace. First one will do an upsert. If it exists or not, it will create. It will create one if it doesn't exist, or update the document if it already exists. Replace one will only update in this case. Now, yeah, table version, pretty much the same thing as well. The only difference is that you don't have the patch method in the table counterpart, because it doesn't make sense. It's not a document, so you would have to set individual column values, basically. Delete, same thing. Also utility methods for it. Works for tables as well. And you can clean up tables and collections by providing a truthy value in the filtering criteria. In this case, on table, that's done using the where method. In the case of collections, it's done directly on the remove method. Yeah, you can create indexes. Of course, you can get metadata out of result sets you obtain from the database as well. Cleaning up, you can drop collections. You cannot drop tables again. DDL for relational tables is not available. You can drop schema. You can drop schemas, and you can close the session, of course. Yeah, so what does this allow you? It allows you to, I believe, simplify and secure your database installation. Simplify in a way that, for instance, if you have a polyglot data architecture and multiple data stores, you are not required to have those anymore, I think. Maybe there might be some performance reasons, but that's a different subject. But if performance is not your main goal, this will help you, I believe. Also, it allows you in terms of finding know-how for this. I mean, a lot of people know how to work with MySQL, DBAs, and stuff like that, so you don't need to find specific DBAs that know how to work with document store data engines, basically. And by using this from the application standpoint, it also helps that you don't have to resort to ORMs, because we already provide a similar kind of functionality. And it's a lot more simpler, and we also allow you to use SQL if that's the case, and if that annoys you, you don't like ORMs or query builders or stuff like that. And you can reap the benefits of SQL in both SQL, as I mentioned. The DevAPI also allows you to adapt to any kind of server setup or configuration. We already touched on this. And yeah, it's if you are like building a prototype or like agile development and stuff like that, it also helps because you have the stuff that comes from NoSQL that will help you there. And if your business scales and then you need to start like doing analytics and stuff like that, you can just simply go back to SQL. And this all works like in whatever kind of architecture. So you don't get stuck to any specific language or platform or ecosystem. So if you have like a microservices infrastructure, this is portable. I mean, if you don't like the performance of a service that is implemented using Node.js, for instance, using the DevAPI, you can always swap it for a Java one or something like that. And you don't have to do a lot because most things are common between the platforms in this case. Yeah, it allows to deploy everywhere basically because you don't have that restriction in terms of platforms. So, and of course you can tap into things like the MySQL availability tools, recent MySQL availability tools like InnoDB cluster, which is a bonus. And yeah, it's all open source, so you are free to review, complain, and contribute. Feel free to talk to me. Some resources here. You should check them out. These are some of the talks that are happening in this conference about MySQL today and tomorrow. Some of them are happening right now, so maybe you made a bad choice coming to this one. I don't know. Yeah, and so that's it. I don't know if you have any questions. Feel free to ask them. And thank you very much for attending my talk.